So now that we have seen the relationship which exists between the coefficient of a polynomial to the zeros of the same polynomial, let's try and solve a couple of problems and try to understand that relationship a little better, right? So now in this question, we have to find the zeros of the polynomial px, which is x cube minus 5x square minus 2x plus 24, right? And we have been given that the product of two of its zeros is 12. So now this is a polynomial in degree 3, right? So there are going to be at least 3 zeros of this given polynomial, right? So now the product of any two of those has been given to us as 12. So let's assume the 3 zeros of this polynomial to be alpha, beta and gamma, right? And we have been given that the product of two of its zeros is 12. So let's assume that the product of alpha and beta, which is alpha beta, is equals to 12, right? Now this is the information that has been given to us in the question. Now we are aware of 3 different relationships, right? The 3 different relationships are alpha plus beta is equals to minus b upon a, right? Alpha beta plus beta gamma plus alpha gamma is equals to c by a, and alpha beta gamma is equals to minus d by a. So now we have the expression of the polynomial. So let's write down the values of all the coefficients in this particular polynomial. So now if we compare this polynomial, px is equals to x cube minus 5x square minus 2x plus 24 to the general form of a polynomial in third degree, we can find out the values of the coefficient, right? So the general form says the px is equals to ax cube plus bx square plus cx plus d, right? So now we can compare these two expressions and find the values of a, b, c and d. So the value of a is the coefficient of the cubic term, right? So this becomes 1, right? The value of b is the coefficient of the x square term, right? So this becomes minus 5. Similarly, the value of c is the coefficient of the x term, which becomes minus 2. And d is the constant term, right? So d becomes 24. So now these are the values of the coefficients of the given polynomial px, right? So now we can use the expression, the third expression, right? Alpha beta gamma is equals to minus d by a to find the value of gamma, right? So we know the value of alpha beta is 12, right? And we can find out the value of alpha beta gamma from that expression. So using these two values, we can find the value of gamma. So let's take that expression alpha beta gamma and calculate its value, right? So the value of alpha beta gamma is equals to minus d by a, right? Now we know the value of d is 24 and the value of a is 1. So the value of alpha beta gamma becomes minus 24 on 1, right? Which is minus 24. So the value of alpha beta gamma we have found out to be minus 24. Now I can substitute the value of alpha beta, which is equals to 12, in this expression to find the value of gamma. So I can say in place of alpha beta, I'll write the value 12. So 12 into gamma is equals to minus 24. Right? So this gives me the value of gamma as minus 2. This gives me the value of gamma as minus 2. So we have found out that the value of gamma, or one of the zeros of the given polynomial, is minus 2. Now we have to find the value of alpha and beta, right, which are the other two zeros of the same polynomial. So we have the expression, the first expression, right, which tells us alpha plus beta plus gamma is equals to minus b by a. So we can use that expression to find one equation in alpha and beta, right? So we can use that expression alpha plus beta plus gamma is equals to minus b by a, right? Now we know the value of gamma, right? We know the value of gamma is minus 2. So now we can substitute the value of gamma and the value of b and a, right, to find the value of alpha plus beta. So let's substitute those values and we get alpha plus beta minus 2, right? In place of gamma we have put the value minus 2 is equals to minus b upon a, right, which is minus into minus 5, right, upon a, right, which is 1. So this gives me the value of alpha plus beta as minus into minus 5 is 5 plus 2, which is 7. So I get the value of alpha plus beta as 7. Now this is one equation in alpha and beta that I have, right? Now we also know that alpha minus beta whole square can be written as alpha plus beta whole square minus 4 into alpha beta, right? We can say that alpha minus beta whole square is equals to alpha plus beta whole square minus 4 alpha beta, right? This is using a minus b whole square is equals to a plus b whole square minus 4ab, right? So we can use this equality and we can find the value of alpha minus beta here, right? So I can write alpha minus beta whole square is equals to the value of alpha plus beta we have calculated earlier, right? So the value of alpha plus beta is 7. So alpha minus beta square is equals to 7 square, right, which is 49 minus 4 times alpha beta. Now the value of alpha beta is 12, right? So 4 times alpha beta is 48. So alpha plus beta whole square minus 4 times alpha plus beta, alpha beta becomes minus 48, right? So this gives us the value of alpha minus beta whole square as 1, right? Or I can also say that alpha minus beta is equals to plus minus 1, right? So if we take the square root on both the sides, we get alpha minus beta is equals to plus minus 1. Why do we get the value plus minus 1? Because if we square plus 1, we again get alpha minus beta square, right? And if we square minus 1, we again get the value 1. So alpha minus beta is equals to plus minus 1. So now this is the second equation that we have, right? So we have the equation 1 which tells us alpha plus beta is equals to 7, and we have the equation 2 which tells us alpha minus beta is equals to plus minus 1. So now we can use these two expressions, these two equations to get the value of alpha and beta. So we found out the value of gamma or one of the zeros to be minus 2, right? And using that value, we figured out two different equations in the other two zeros, right? Alpha and beta. So we found the equation alpha plus beta is equals to 7 and alpha minus beta is equals to plus minus 1. So now we can solve these two equations to get the value of alpha and beta. So what we'll do is we'll add these two equations, right? So I have alpha plus beta is equals to 7, right? And let's take the first value which is plus 1. Let's take the value plus 1. So alpha plus beta is equals to 7 and alpha minus beta is equals to plus 1, right? Now if I add these two equations up, right, we get 2 times alpha is equals to, so plus beta minus beta cancels, is equals to 7 plus 1, right, which is 8. This gives me the value of alpha as 4, right? Now if I put this value of alpha is equals to 4 in alpha plus beta is equals to 7, right? So if I put the value of alpha is equals to 4 in this equation, I get 4 plus beta is equals to 7. It gives me the value of beta as 3, right? So using this equation alpha minus beta is equals to plus 1 and solving with alpha plus beta is equals to 7 and alpha minus beta is equals to plus 1, I get the value of alpha as 4 and beta as 3, right? But we have one more set of equation, right? We have alpha minus beta is equals to minus 1. So let's solve with alpha minus beta is equals to minus 1 as well. So we get alpha plus beta is equals to 7, right? And alpha minus beta is equals to minus 1. Now if we add these two values up, we get 2 times alpha plus beta minus beta cancels is equals to 7 minus 1, right, which is 6. So this gives me the value of alpha as 3, right? Now if you put the value of alpha is equals to 3 in this equation, right, we get instead of 4 plus beta, we get 3 plus beta, right, is equals to 7, which again gives me the value of beta as 4. So if I use this expression or the value of alpha as 3 and I put that value in alpha plus beta is equals to 7, I get the value of beta is equals to 4, right? So using this equation, I get the value of alpha as 3 and beta as 4. Now these two values, they are the same, right? It doesn't matter which value is alpha and which value is beta, right? Because these two values we have just assumed, right? So we have assumed the three zeros to be alpha, beta and gamma. So these are just assumed values. So the thing to note here is that the two zeros that we have are 3 and 4, right? Anything can be alpha and anything can be beta. So the two new zero values of the given polynomial that we have found are 3 and 4. Right? So we can say that the three different zeros of the polynomial that we have are -2, 3 and 4. So these three values are the zeros of the given polynomial x cube minus 5x square minus 2x plus 24. Right? So this is how we can use the relationship between the coefficients of a given polynomial to the zeros of the same polynomial, right? To find the values of the zeros of the polynomial. Now let's move on to the second question, which is again based on the concept of the relationship between the coefficients of a polynomial to the zeros of the same polynomial, right? So in this question, we have been given that alpha and beta are two zeros of the polynomial fx is equals to x square minus 5x plus k, right? Such that alpha minus beta is equals to 1. So we have been given that the difference between the two zeros of the polynomial fx is 1, right? So alpha minus beta is equals to 1. What we have to do is we have to find the value of k. So this is an unknown in the polynomial, right? The polynomial is x square minus 5x plus k. So there is an unknown value there, k. So we have to find the value of k. Now we know that there are two different relationships that exist for a quadratic polynomial between the coefficients of the polynomial and the zeros of the polynomial, right? So now these two relationships are alpha plus beta is equals to minus b upon a, right? So the sum of the two zeros of the polynomial is equals to minus b upon a. And the second relationship is alpha beta is equals to c upon a, right? Or the product of the two zeros of the polynomial is c upon a. Now we can use all the information that is given to us to calculate the value of k. So first, let's figure out the value of all the coefficients of the given polynomial. To do that, what we'll do is we'll compare the polynomial x square minus 5x plus k to the general form of a quadratic polynomial, right, which is ax square plus bx plus c. So if we compare these two expressions, we can easily write the value of a as the coefficient of x square, right, which is 1. The value of b becomes the coefficient of x, right, which is minus 5. And c is the constant term in the equation, right, so which becomes k here. So we have the value of all the coefficients, right, a is equals to 1, b is equals to minus 5 and c is equals to k. Now we can say alpha minus beta whole square is equals to alpha plus beta whole square minus 4 alpha beta. Now if we use the equation a minus b whole square is equals to a plus b whole square minus 4ab and we put the values alpha and beta in place of a and b, we can write this expression, right? Alpha minus beta whole square is equals to alpha plus beta whole square minus 4 times alpha beta. So now we can put the values of alpha minus beta, alpha plus beta and alpha beta in this equation and get the value of k, right? So the value of alpha minus beta has been given to us in the question, right, as 1. So here we can write 1 square, right? So in place of alpha minus beta, we can write the value 1 is equals to the value of alpha plus beta is minus b upon a, right? So we can write the value of alpha plus beta as minus b upon a, which is minus 5 upon 1 whole square, right? Minus 4 times alpha and beta, right? So alpha beta is c upon a, right? So the value c upon a is k. So we can write 4 times k upon 1, right? So if we simplify this further, we get 1 is equals to, so minus into minus 5 is plus 5 and 5 square is 25 minus 4 times k, right? If we simplify this further, we get 4k is equals to 24, right, or k is equals to 6. So the unknown value that was given to us in the polynomial x square minus 5x plus k is actually 6. So this is how we can use the relationship between the coefficients of the polynomial and the zeros of the polynomial to either find the zeros of the polynomial or some unknown values which is given to us in the polynomial. So this is how we use the relationship between the coefficients of a polynomial and the zeros of the same polynomial.